Okay, so 12.2, we're doing multiplying matrices. And there's basically two main types of this one that we're going to do. The first type we'll do will be the easy part, which is scalar multiplication. And with scalar multiplication, this is where if you have a matrix that's just make it real quick and real easy here. Let's say it's 1, -3, 5, and 0. And maybe one of those things like this. So if A is 1, -3, 5, 0 for the matrix, they may tell you to find 3A. And scalar multiplication is really straightforward, really easy. That all you have to do is just take every single number in here and multiply it by 3. So 3A would just become 3, -9, 15, and 0. And that's it. That's all you have to do. So scalar multiplication, really straightforward, really easy when it comes down to it. Probably what they're going to do in most of these questions, though, is they're going to make it so it's a combination of scalar multiplication, and then they're going to put in some addition and subtraction like we were doing yesterday. So more than likely on these, if this was example 1, most of them will probably look more like this. So let's go with 2, 8, -3, and -1, 5, and 2. And let's let matrix B be -1, 0, and 5, 0, 3, -2. And they'll probably do it where it's a mix of adding and subtracting and scalar multiplication. So they'll tell you to do something like this, where you're going to find 2A minus 3B. Okay, now if it was addition, it would be really straightforward. You know, nothing to kind of worry about anything at all in this part of it. For what we're doing for this part of it today is if it's 2A minus 3B, you can look at it like this, but you can also think about it as being like 2A plus -3B. That sometimes people are like, well, does that mean we need to do -3 times B, or need to do 2A and 3B and then subtract those two numbers? I'm kind of one of more of those that if y'all do addition, y'all usually don't make as many mistakes. So if we're going through the scalar multiplications in here in section 2, if they give you a subtraction problem like this, I would think about rewriting it as like 2A plus -3B, so that we can then go back and actually kind of do the pieces there separately. So first thing is, let's do 2A. So we'll take matrix A and multiply everything by 2. So that's 4, 16, -6, -2, 10, and 4. Okay, and then that way we're going to add and go ahead and do everything in B times -3. And you can do it either way, but to me, a lot of times if it's an addition problem with these, it's a little bit less complicated when we're going through things. So, all right, so doing -3 times all these, it's going to make that a +3. 0, -15, 0, -9, and a +6. Okay, and then again, because it's addition, it's a little bit easier. Now we're just going to go back and put it all together. So it's 4 plus 3, so that's 7. It's 16 plus 0, which is 16. It's -6 plus -15, which is -21. Okay, and then moving to the second row, it's -2 plus 0, which is -2. It's 10 plus -9, which would be 1. And it's 4 plus 6, which is 10. Okay, so there's your answer for 2A minus 3B. The second thing we're going to do is similar to this, but it's a little bit different when you're going through these, and there's a couple options you can do. and I'll show you both options that you can do for this one, that they're going to ask you to solve a matrix equation with scalars. So it's a solving equation, but this time it's going to be with matrix, and we're going to have some scalar parts of it in yesterday. Because yesterday we were doing it where we just had to add, subtract matrices to solve an equation. We're still solving an equation today, so we're going to do some adding and subtracting along the way. But then because it's scalars, we've got a little bit of multiplication, a little bit of division that we'll kind of do at the same time for this one. Okay, so here's what it's going to look kind of like. We'll do 3x minus 2 times -1,570 equals 17, -13, -70. Okay, so here's another one where you've kind of got some options. You can either, now you've got the scalar multiplication here, so you can either do 2 times this one to make it a subtraction problem, or you can do -2 times this one to make it an addition problem. To me, whichever way you look at it, it's fine for this one. But because of how this thing is set up for this part of it, let's just go ahead and just pretend like this was a 2, and then we'll come back and put the 3x minus that's in front of it. So first thing is, let's just do 2 times everything in here. So we've got 2 times -1, which is -2. 2 times 5, which is 10. 2 times 7 for 14, and then 2 times 0 for 0. Okay, so now that part of the scalar multiplication is gone, now it's almost like a regular equation because it's 3x minus something equals something else. And you can think about these as just being big whole numbers. If this was 3x minus 2 equals 17, your next step from here would be to take this part that's a minus, this matrix, and to get rid of that one, just like this was 3x minus 2 or 3x minus 14, we would add 14 to both sides. So for this one, we're going to do the same thing. We're going to add this thing to both sides. So do the same thing here. So -2, 10, 14, 0. Okay, so if you were doing a minus -2, that would be a positive 2. 2 plus a -2 will wind up going 0. So all this over here is going to cancel out. So that'll leave you with 3x equals, and then over here, again, this is where it's a little bit easier. It's 17 plus -2. 17 plus -2 would be 15. It's -13 plus 10, which would be -3. It's -7 plus 14, or 14 minus 7, which would make that 7. And this one is 0 plus 0, which winds up being 0. Okay, I'm going to bring that in just a little bit tighter here. Okay, and then the last step for this problem is if it was 3x equals 15, we would take both sides and divide it by 3. So we're going to do the same thing here. We're going to take every single number in here, and we're going to divide it by 3. So that those 3's would cancel and would leave us with the x. And now we just go back in here and divide every single number by 3. So 15 divided by 3 is 5. -3 divided by 3 is -1. If we do 7 divided by 3, it's not a whole number. So in that case, just leave it a fraction, make it 7/3. And then 0 divided by 3, of course, would still be 0. And And that way we get what matrix X we want it to be. Okay, now here's the second way, and you don't necessarily, if that makes sense and you're good with that one, let me show you a different way that you could look at these if you get to one and you kind of get stuck and you're not sure exactly how it's going to work. That if we were to go back on this one, and just so you could kind of see what it is it would look like. If we went back to the original problem that we had up here, it's a little bit longer way, but I've had some people that were doing this, it didn't quite click with them. And I told them, I said, all right, well, here's one thing you could do. You could take this solve an equation matrix that you have here, and you could do it one location at a time. You don't have to do this, and it does take a little bit longer to do this. But I'm just going to kind of show you just the setup on this one, and you can, if you don't want to do this, if you want to stick with what we're doing back here, doing the whole matrix, that's fine, because this is actually a quicker way of doing it. Doing it one location at a time, it's going to be a longer way, but some people like it because it's okay. So what we'll do is we'll just take it, so we're going to work with just the first corner that's up here. So it's 3x minus 2 times -1 equals 17. -2 times -1 would be a +2. And then we'll solve that equation. Okay, and then we get 5. And since that came in the first corner, then that 5 would go into the top left corner that's up there. Okay, and then you could do the same thing in the next, you could do it up in the right-hand corner there. That you could take 3x minus 2 times, well, then we could go to the 5 that would be here and set that up so it's with the -13 here. Solve that equation. Since this came out of the top right, you put that answer in the top right. And then you could go back and do it for the bottom left corner, and then you can do it for the bottom right corner. And you can solve it one piece at a time and then bring it all back together. It takes a little bit longer. And some people were like, okay, well, I'd rather do, because I remember one year I was doing this and I showed them this and they were all like, I don't get that. That doesn't make any sense. And then I showed them this and they're like, oh, we got it. And I'm like, okay, that's fine. I don't care. As long as it makes sense, whether you do it one big matrix at a time to find it, or you want to go back and find the matrix one piece at a time, I don't really care. As long as you can get the answer, either way is fine. Because you'll wind up getting the same answer no matter what you do. So there we go. That was 5 -1. The answer we had back here was 5 -1. So you can get the answer either one of two ways. Just depends on how you want to get there. This is the quicker way to do the whole matrix all at one time. But again, you can do it one piece of a matrix at a time or one location at a time. Just takes a little bit longer, but you'll still get the same answer. So either one you want to do there is fine. Okay, so here's the big piece. Here's the last thing we've got to do that kind of puts it all together, because that was kind of a walk up to it. Here's where we're actually going to multiply one matrix by another matrix. Okay, and to multiply one matrix by another matrix, you multiply all the rows of the first matrix by all the columns of the second matrix. Okay, and what we said yesterday when we were adding and subtracting matrices, we said that if you're going to add and subtract a matrix, they both had to be exactly the same size. To multiply a matrix by another matrix, the setup's a little bit different. They don't have to be the same size, and in most cases, they aren't the same size. The setup for how you set these up is that we'll say it this way. For matrices to be multiplied, comma, because this is where you have to kind of put it all together. For matrices to be multiplied, the columns in the first matrix has to be the same, or say has to be equal to the rows of the second matrix. Okay, so if the columns in the first matrix, if you have 4 columns in the first matrix and you have 4 rows in the second, then those two things match up, and then you're good to go. You can multiply this thing out. The answer you get from that the size of the matrix you would get from that answer, the resulting matrix size, would be the rows of the first matrix by the columns of the second matrix. Okay, now that's a big, if we squeeze all that together, that's a big paragraph to describe everything you have to do. It's a lot easier to look at something and figure it out, because let me just show you one here in a second where if we're going to do one. We're going to see if we can do something like this. Let me just kind of give you one that kind of matches up for this thing. So let's just kind of do this. Let's say that if A is a 2x4 matrix, and B is a 4x3 matrix. Oh, sorry, squeeze it up a little bit. Can you find A times B? Okay, now, and again, if you've got to check it, and again, we'll actually do this on the next one. This one, I just want to kind of give you some numbers so you can see what it would do. Is that if you do A times B, here's all you do. You write down what size A is. So A is a 2x4 matrix. You write down what size B is. It's a 4x3 matrix. To make it work out, these two numbers in the middle have to be the same. So as long as these two things are the same, then yes, you can multiply it together. So can you find A times B? Yes, you can. You can actually multiply these two together. And then the size of the new matrix the size of A times B is really easy. It's the numbers you've got left over. It's 2 by 3. So if the middle two numbers are the same, basically they're going to cancel each other out, if you want to think about it that way, because the way it matches up. And then the size of the matrix that's left over is going to be the first number here and then the number that you've got here that's in the second matrix. So really easy to figure out if you can multiply them together, and really easy to figure out what the size is going to be. Okay, now, and here's the thing is, if we flip this thing around, can you find B times A? Well, if we reverse this thing around, B is a 4 by 3, A is a 2 by 4. These two numbers don't match up. So if they don't match up, then no, you cannot. And I think every single problem that you have when you're going through the homework, they'll always give you an option that, can you find the matrix? Okay, if you can, then go ahead and tell me what the matrix is. And then there'll be a part B that just says, no, you can't find this matrix. So some of the problems that you'll get, you won't be able to multiply these two things together because the sizes don't match up. Okay, so again, big wording, a lot of wording here to kind of get through this one. But when you see it, it's really easy. Okay, I take this size, I take this size. If the middle two numbers are the same, I can multiply it. And then this is the size of the matrix that I'm going to have at the end. If the numbers in the middle aren't the same, then no, you can't do that thing together. Okay, so that's your checker. Before you actually start multiplying out, that's the one thing you've got to check. Let's do a couple of problems where we're going to actually go through and multiply these together so you can see it. And after we do two of them, that's all we're going to do. Because now if we were digging into this, if we had more time to go in and do sections 3 and sections 4, we'd spend a lot more time doing these. But for what we got to do today, because this is the last thing we have to do, we'll just show you a couple of problems. And then once you've got these couple of problems, that will get you through pretty much everything that you've got to do. And then we'll be okay from there. So, okay, so here we go. Last two problems of the year. So for this one, example, or for matrix A, we'll say that it's 2, 1, negative 3, 0. And B is negative 1, 3, 0, 4 for that matrix. Okay, and if they're square, it makes it really easy because the size on this one is a 2 by 2. Size on this one is a 2 by 2. Because remember, you always want to do the rows first and then the columns second. That, to me, that's the biggest thing, is remembering which one is which. So, having the notes out in front of you when you do the homework, then it makes it a little bit easier. But again, the square ones are easier because, it's 2 by 2. There's 4 numbers, so it's got to be 2 by 2. So let's find. Sometimes I'll just put AB like that. Sometimes they might actually put that it's A times B with a dot in the middle. Either way that they'll go, that basically means the same thing. Okay, and again, we're always going to do the rows of A times the columns of B. So it's always going to be that same thing. You're going to take all the rows in A, multiply it by all the columns in B. So we're going to start off with the first things first. The first thing is we're going to do the first row of A times the first column in B. So the first row of A is 2, 1. The first column of B is going to be at negative 1, 0. And if you can get this, then everything else we're going to do is exactly the same thing. To multiply these parts of it together, here's all you have to do. You're going to take the first number in the first row here, you're going to multiply it by the first number in the column that's here. So you're taking the first row here, first number here, and multiply it by the first number here. So 2 times negative 1 is going to be the first part. And then you're just going to add that to whatever you get when you multiply the second number here by the second number here. So that's negative 2 plus 0, which is just negative 2. Okay, and so whatever rows and columns you have, we're going to go back and put the answer back up here at the end. Since this is the first row in the first column, this answer goes into the first row and first column, so it will go in that 1, 1 location. So whatever you do here, this is the answer that you're going to put, and this is where you will put it. If it's in the first row in the first column, this answer has to go in the first row in the first column. Okay, so after we do that one, now we're going to do the first row of A, and there's one more column that we have up here. So now we're going to multiply this times the second column. So we're still going to do 2, 1. But now we're multiplying by the second column, so that's going to be times 3, 4. Okay, and honestly, the hardest thing on this one is just making sure you don't jump around and move locations. The hardest thing is just staying focused and making sure that you're doing the first row and the second column and you're not mixing anything up. So it's not really hard. You just have to stay focused when you go through this thing and go through the steps. Okay, so it's 2 times 3 plus, and then we're going to do 1 times 4. So that is 6 plus 4, which would be 10. Okay, and again, location-wise, we're going to stay in the first row, but now it's the second number, because again, the column is just the second number, the third number, the fourth number, that kind of thing. So the first number in the first row needs to be -2. The second number in the first row needs to be 10. And again, if you go back up here to this one, the 2 here and the 2 here matches up. So those cancel out. So that means the answer we're going to have when we do A times B is going to be a 2 times 2 matrix. But again, if they're all the same size, if they're squared, that makes it easy because it's always going to match up. Okay, so we've done everything in the column-wise we could do. There's no other columns, so now we're going to go to the second row. And then we're going to start it over. So now we're going to take everything in the second row, and now we're going to multiply it by the first column that's here. And then we'll do the second row we have here times the second column that's here. Okay, so the second row of A was -3, 0. And then we're back to the first column that we had here, so we're just going to repeat this column that we have here. And some people kind of go, well, that means that if there was a third row, we would take that third row that was here, we would still multiply by -1, 0. Yes, so you would just keep going down this line. That if we had more rows, we would just keep multiplying every single thing here by -1, 0. So it's -3 times -1. And then plus 0 times 0, which is easy because that's just 3 plus 0, which is 3. Okay, again, this will be the second row. This will be the first answer that's in the second row, if you want to think about it that way. So that 3 would go right underneath the -2 we had here. So when you're doing these, when you get finished with it, you can always think about it that way, that this is the second row, and this will be the first answer that goes in the second row, if you want to think about it that way. So for this one, again, we're going to do the second row now, which again was a -3, 0. But now we're going to use the second column, so now we're going to use column 3, 4. So it's -3 times 3. And the good news is with this second number being 0, when we do 0 times 4, this is always going to come out to be 0. So it's just -3 times 3, which would be -9, plus 0, which would be -9. So in the second row and the second column, we've got to put in a -9, which would put us right there. And that would be the final answer that we're looking for. Okay, and I'll put that answer again at the bottom down here. So okay, now again, you could flip this thing around. They could also ask you to find B times A, and it should give you a different answer because you're going to do a different order of things. But for this one, we're just going to worry about A times B because they're both a 2 by 2 matrix, so it's really easy to see it, really straightforward when you kind of look at it. Okay, for the last one, what we'll do, let me give you one that's a little different look to it, so it's not a nice square matrix. Give you 2 matrices that are a little different sizes so you can see how it looks, so when the matrices look totally different when it comes down to it. Because this one, again, pretty easy because everything was a nice square matrix and we wind up with the same square matrix. Give you some of these where they're not square matrices so you can see that the answer will change up a little bit when we go through this one. All right, last example of the year. I know, it's just sad, right? Nobody, you don't have to cry. You can hold it in. Be brave. Okay, so for example 2, matrix X, 10, 1, 0, 9 for row 1, 6, 0, 0, 5 for row 2. And again, if underneath that, if you want to kind of make sure, this would be a 2x4 matrix. Because again, you've got 2 rows going this way, and you've got 1, 2, 3, 4 columns. So it's a 2x4 matrix. And Y is 6, 3, 2, 1. And sometimes one like this throws people off a little bit because they go, what do we do for size here? So again, for the size of it, if this had 2 rows, this one you're going to have 1, 2, 3, 4 rows. And you only have the 1 column that's here, so it's a 4x1 matrix. So for this one, we're going to find x, y. Okay, now in this one, we're going to do this on the side. Could you find y times x? Can you do a 4x1 by 2x4? Couldn't, could you, right? Because this one, the middle 2 numbers have to match up. These don't. So if they ask you to find y times x, you would not be able to do that. Now, x times y is okay because, again, if you put these 2 together, you've got 2x4 and a 4x1. Your middle 2 numbers match up, so that's good. Which means that the answer is going to be a 2x1 matrix when we get done with it. So if they ask us to find x, y, I'd go ahead and figure out what size it is. That way, at least you've got some idea of what it's going to look like. We're going to have 2 rows and only 1 column when it comes back to it. Okay, so when we're doing x, y, we're going to do the first row of x times the first column of y. So that's 10, 1, 0, 9 times 6, 3, 2, 1. And there is only 1 column, so there's only so much we can do with that one. Just pull it down so we can see it. All right, and when you multiply these together, again, it's just the first number here times the first number here. So it's 10 times 6 plus 1 times 3 plus 0 times 2 plus 9 times 1. So that's 60 plus 3 plus 0 plus 9. That's 63 plus 9, which would end up making that out to be 72. Okay, and again, we said we're going to have, it's a 2x1, so we're going to have 2 rows and only 1 column. So this is going to be the first answer that goes in the first column. And since this is the only column that we have, well, now we have to go to the second row and multiply that by the first column, because there is only that 1 column, so that kind of cuts down on the work that we have to do here. Put this here so we kind of. Okay, so second row was 6, 0, 0, 5. First column again, 6, 3, 2, 1. Okay, and the zeros in the middle again make the work a little bit easier because we're doing 6 times 6. We're doing 0 times 3. We're doing 0 times 2, and we're going to do 5 times 1. So that's 36 plus 0 plus 0 plus 5. And that's 41. So that goes in the second row, and that's the first answer that's in the second row, and that's, again, the only answer that's in the second row. And there you go. There's your number we're looking for. Okay, and there's the answer to matrix x times y, 72 and 41.